Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the Easy Learn, and we're going to discuss a new topic here, that is superconductors, and of course introduction to electronics is. So we are going to discuss a brief introduction about the superconductors, and let's start. Superconductors, as the name suggests, conductors means any device through which any material through which electrical current can pass. When we discuss the super, it means that it is an ultimate conditions, and the super means that in ideal condition it shows that maximum conductivity, and it shows zero resistance when the current flows through it. Superconductivity, there is a correlated term to the superconductors. Superconductivity is the phenomena of exactly zero electrical resistance and expulsion of magnetic flux field occurring in certain materials. So certain materials, this is the first thing right now need to be noted, that not every material, this is very rare. So certain materials called superconductors. Superconductors are the materials, while this is the process and the phenomena that we are going to use on the certain material for showing their behavior as a superconductor, or they behave as a superconductor when the phenomena we are going to apply to make sure that they show zero electrical resistance, and this process is called superconductivity. And the process, what is the process? We are going to cool down some electrical material, certain electrical material, cool down below the characteristic critical temperature. So critical temperature is always discussed in the Kelvin scale as from the beginning. So we are also using the Kelvin scale. It is basically the history. If we're going to discuss the history, it is a Dutch physicist, Heike Kamerlingh Onnes. It is basically the professor who discovered on April 8, 1911 in Leiden. Basically, he discovered that the temperature, if goes close to 0 K, not exactly 0, but when it goes to 0 K, he was performing the experiment on mercury, and he noticed that it shows approximately zero electrical resistance or negligible electrical resistance, and that we are not able to measure this electrical resistance, so we can say that is zero electrical resistance, and that is achieved at 0 Kelvin, and this process is called superconductivity, and this is a superconductor. He discovered first in 1911 that mercury behaves this characteristic at 0 Kelvin. So he was given this credit, and he receives the Nobel Prize in 1913 after the 2 years. This is the picture of the professor who discovered this Dutchman. It was soon discovered that not only the mercury but other metals and alloys are also available that show the same behavior of the superconducting when the temperature goes approximately to 0 Kelvin. That is a very low temperature. There is a big issue, but not only one issue, but there is a big issue. One of the big issue, that is how we can achieve such a low temperature, 0 Kelvin. And the second issue, minor issue, is that how many material and metals are available that are best suited to this superconducting behavior, and how much electrical current can pass through them at that temperature. These are many issues that are passing through the minds of the scientists that are performing these. But right now, at that time, the main issue is how to achieve 0 Kelvin temperature. The lack of the electrical resistance means that the large currents can circulate. So that's why we are saying that superconductors, if large current can circulate through the coils, if that is how it is related. Superconductors are related to the previous topic. We are discussing the magnets and magnetic fields. So when large currents can circulate through the coil, we are discussing the coil of the previous episode, that is the solenoid. So if we replace the previous episodes, the coil was made up of the copper, and if we replace it with the superconductor materials, suppose there is a material that is a superconductor at 0 Kelvin and it shows negligible resistance, So when we apply the same amount of the current as in the previous episode, it shows the magnetic field in a maximum magnetic field as compared to the previous time. So when it shows the maximum magnetic field, we can perform the better functions, we can achieve the better efficiency. So that is the target of basically superconductors. This is an basically use of that superconductor. It is used in the cancer treatment. It's very sensible, very critical matter. We have no compromise there. That's why we're discussing superconductors here. Physical research is also very critical. If we ignore some functions here, we cannot research, and of course discoveries are related to it. These scientists never compromise things. So the superconductors are basically used here. This animation shows that the operation of the linear accelerator, widely used in both functions, cancer treatment and the physical research. There is a particle accelerator machine here. This is the particle accelerator machines that uses the electromagnetic fields to propel charged particles. These are the charged particles that are coming out from this machine at a high speed and energized. This is basically slow motion, and this will throw many particles in the single you can say that single cycle. While another important thing is that you have to understand this length. This is the first electrode C1. Its length is small and gradually increasing length towards this side, C2, C3, C4. This is the very carefully controlled, and our mission is to take care of these particles, and where the voltage is applied, which changes its polarity as the electrode passes through it, which is carefully controlled. You can see the positive and changes to negative, positive. Assume that this charged particle has a positive. Red shows positive, so it means that when it goes through this way, it is carefully controlled. And here there is a oscillator here, which provides us the voltage and sinusoidal output voltage in the form of the radio waves, and that is connected here, C1, C2, C3 and C4. And basically this is another topic, and we are not going to discuss it in detail, but I just want to show you here that this is an example of this is the application of the use of the superconductors in the professional or the physical application. However, the required temperature can be achieved. We can achieve at that time, in the previous time, in 1980s, when it was discovered, the not the 1980s, 1911 it was discovered, and 1930 he received the Nobel Prize. And that time, it is the basic issue the scientists are facing is that how they can achieve such a low temperature. 0 Kelvin is very low temperature. They can achieve this temperature at that time, the cooling agent called liquid helium. But issue is this, that liquid helium, you can see in the diagram, is very expensive and difficult to handle. Even if it touches the 4.2 Kelvin at 1 atm pressure, it will start boiling. And right now this diagram is taken at these temperature condition, 4.2 Kelvin and 1 atm, and it is in the vacuum tube, and it is its boiling procedure. From here you can see that, and it is very difficult to handle, and it is expensive too. Then in 1980s, a group of the workers with IBM demonstrated that why we are going to use the mercury and these type of the semiconductor materials that need 0 Kelvin. We can use the ceramic materials also, and that need not 0 Kelvin, but the temperature is not mentioned here, but whatever the temperature they need, it can be achieved by cooling through the liquid nitrogen. And liquid nitrogen is relatively cheap as compared to the previous method. Over the next few years, the other researchers also found a very big breakthrough, that the superconducting at these relatively high temperatures. So there are the more materials like semiconductor, and there are other materials also which can behave as a superconductor at relatively higher temperatures. So we are not going to attain the 0 Kelvin, and we can use that at higher temperature. Basically our goal, I will show you at the last slide, our goal is to achieve a superconductor that can behave as at 0 electrical resistance at the room temperature. That is the basically target of the scientists. Okay, although many different superconductor ceramics have been discovered, no doubt, and many attempts to make them in bulk, but not yet successful. You know, when you go to the market, you will not see the superconductors available everywhere. So they are not available in the bulk material, and or to form them in the wires have not been successful. So, and we are not using them in our wiring system of the homes. So it means that we are not successful to use the superconductors. So big losses of the electricity everywhere, because these wires are not superconductors. They have electrical resistance as well. If too high current, there is another issue facing right now. If too high current is passed to the superconductors, they cannot bear. The superconductivity breaks down, and this is also a big issue of the superconductors these days. This is our goal and the target of the scientists, as I discussed in the previous slide, that as yet unrealized is to find a substance that is superconducting at a room temperature, so that we can use in the form of the wires, because wires are behaving at the room temperature. Many electrical appliances like computers and any other things, they're using the wires inside, and they are behaving usually at room temperature. So this is the target. Myriad of the uses, including lossless power transmission. This is a very big use. We want to use it for that purpose. So right now this is enough, and we will discuss our further discussion will be continued inshallah next time. Take care. Allah Hafiz.